Okay, so in the previous video, we looked at these examples and we learned how do we find the different parts and pieces of a quadratic function from the two different forms of the equation. Okay, and we talked about that. We also looked at how to find it using the calculator. So let's now go and look at the sample problems. Okay, sample problem A says find the characteristic parts of each function. Use this information to produce the graph. What do you notice about sample problem A? Is it in standard form or vertex form? If you compare to the ones on the chart, this is in standard form. In standard form, we need to know what is A, what is B, and what is C. That way we can find all the parts. So look at this one, and A is -1. Okay. B is 6, and C is -2. I got that from this equation. A is -1, B is 6, C is -2. Do you remember what your chart said about finding the vertex? When the equation's in standard form, it said to do -b over 2a, which is -6 over 2 times -1. That's -6 divided by -2. That's 3, right? So the x-coordinate of our vertex is 3. How did we do that? We did -b over 2a. Look back at your chart that's on the first page. Now, how do we need the other part of our vertex. So we're going to take that 3 and plug it into this equation. I'm going to come over here and do y equals -3 squared plus 6 times 3 minus 2. All right. So 3 squared is 9. The opposite is negative, so that makes that a -9 plus 18 minus 2. What have I done? I've taken what I got for -b over 2a and replaced each one of these x's with that 3. -9 plus 18 is 9. 9 minus 2 is 7. So that's the other part of our vertex, 3, 7. So it says to use these parts to produce the graph. Let's do the other parts first. Axis of symmetry. Axis of symmetry, we look back on your chart. What does it say about axis of symmetry from standard form? It says x equals -b over 2a. Well, we already found -b over 2a. It was 3. The y-intercept is told from our equation. The chart says 0c, so this is 0, -2. Okay, now let's look at graphing. The vertex is 3, 7. So I'm going to go 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. Axis of symmetry is x equals 3. Remember that always goes through the vertex. Do you know what happens with this negative in front of x squared? That's going to make our parabola open down. I don't know if you remember that from your algebra 1. You remember it from absolute value. If the first term is negative, whatever it is opens down. Okay. What else have we got? The y-intercept is 0, -2. Now I need a point symmetric to the y-intercept. So think about, this is -2, right? How far is that from that dotted line? It's 3. 1, 2, 3. So go 1, 2, 3. And that's going to be 6, -2. It has the same y value as the y-intercept. It's the mirror image across that axis of symmetry. What else do we need? X-intercept. Okay. So this one If we draw this in, it's really kind of a sketch. This one actually comes up with decimals. You can't exactly see where the x-intercepts are from sketching that graph. So let's go back to our friend Desmos. I'm going to clear these two off that we did in the previous problem. And what's happened in the equation from the problem is negative x squared. There we go. Negative x squared plus 6x minus 2. And there's my parabola. I can zoom it just a little bit if I want to see. What did we talk about? We said that the vertex was 3, 7. See if we were right. Whoa. Vertex is 3, 7. We said the axis of symmetry was x equals 3. That's true because that line, that vertex, axis of symmetry goes through the vertex. We said that the y-intercept was 0, negative 2. That's right. We said the point symmetric to the y-axis was 6, negative 2. Do you see how close that is? Let's see if we can get a little bit closer. It's hard to make that exact. There we go. I want to make it stay. It doesn't want to stay. Okay. Now, what do we need? The x-intercepts. So I can go right here and find this x-intercept is 0.350. And this x-intercept is 5.650. You can round it to 2 decimal places. What else do we need for this one? We need the table. So I can go here to this gear and click the table. And there it is. And I don't think your packet doesn't give you numbers you have to start with. So you can put whatever numbers you want to in the table. I would put some on this side of the parabola and some on this side of the parabola. And if you need more, remember with Desmos in the table, if you need more numbers, you can type in more numbers. Right? So you can fill in your table. The 3 important letters in standard or general form are A, B, and C. What did we learn in that one? The negative makes the parabola open down. Okay, and we used our chart and those parts to find the vertex and axis of symmetry. It's important that you can do it by hand, but you can also use your calculator to check your work. All right, let's look back at your paper. We did that one. I'll leave the table for you to fill in. This is our other sample problem. What form is this one in? Do we have ax squared plus bx plus c like sample problem A, or do we have the a, h, and k? This one has the a, h, and k. It has the parentheses. That's kind of your clue. This is vertex form. Vertex form is a times x minus h squared plus k. So your vertex, let's find our letters. What's A? A is 2. What's H? Remember the formula is x minus h, so our h is negative 1, and our k is 3. Look back at your chart. This one is the easy one to find the vertex. The vertex is hk, so this vertex is negative 1, 3. Let's go ahead and throw that on the graph. Negative 1, 3. Axis of symmetry. Look back at your chart. Remember, it's always going to go through your vertex, so the axis of symmetry is going to be x equals negative 1. Let's go ahead and draw that in. Which way is this parabola going to open? This one's going to open up because the A is positive. What's next? The y-intercept. Now, it's not quite as easy to find the y-intercept from vertex form, but the chart says to plug in a 0 for the x. So I have 2 times 0 plus 1 squared plus 3. Took the equation from the problem, replaced the x with 0. Parentheses first, 0 plus 1. Exponents next, 1 squared is 1. 1 times 2 is 2. 2 plus 3 is 5. So my y-intercept is 5. If the y-intercept is 5, this x-coordinate is always 0. So let's put that in, y-axis 0, 5. No, sorry, not the y-axis. Y-intercept. Can't talk today. Okay, point symmetric to the y-intercept. How far is that y-intercept from the axis of symmetry? It's 1 unit, so go 1 the other way. And this is negative 2, 5. This one's also a little bit easier to find from the calculator. Now, think about this. Here's our point symmetric to the y. Let me go to the dots. There we go. So here's this parabola going to go like this, right? You know, this word vertex means turning point. The vertex is where that parabola turns. What's our other thing we're supposed to find? X-intercept. Does this have any x-intercepts? It does not. All right, let's look at this one in the calculator. Come on, Desmos. Cooperate with me. There we go. This one is 2 times x plus 1 parentheses squared plus 3. Let's check our work. Vertex we said was negative 1, 3. Axis of symmetry was x equals negative 1. That's right. It's always going to go through the vertex. Okay. Y-intercept, 0, 5. That's what we said. Point symmetric to the y-intercept is here. It's the mirror image. That's negative 2, 5. If you can get it exactly, there it is. I don't know why it won't leave that one on there for me, but there's negative 2, 5. X-intercept obviously does not cross the x-axis, and then your table. And again, it doesn't tell you where to start your table, so you can start it. I would make sure that you have some points that are on this side of the parabola, some points that are on this side of the parabola. Because if somebody graphed from your table, you wouldn't want them to only graph this side, right? So you want some points from here, some points from there. Okay, those are the 2 sample problems. And then your assignment is you have some practice problems. Number 1 and 2 and 3 and 4. Some are standard form, some are vertex form, and you're going to do just like we did and fill in the parts, and fill in the graph, and fill in the table. I want you to understand how you get those by hand, but you can also use the calculator. I want your graphs to be accurate. The vertex needs to be in the right place. Axis of symmetry shown with a dotted line in the right place. Y-intercepts in the right place. X-intercepts, if there are any, in the right place. And the table. Okay? All right. We'll talk to you later.